The demand for monorail service in Las Vegas in 2005 could be approximated by Q equals negative 4,500 P plus 41,500 rise per day when the fare was P dollars. We are given the supply equation in terms of P, the price. P is the price and Q is the quantity, the number of rides. In September 2005, the Las Vegas monorail increased the price from $3 per ride to $5 per ride. What was the effect of the price elasticity of the demand? What does the answer suggest about the fare corresponding to maximum daily revenue? For part A, to answer this question, we would need to find the price elasticity of demand E. The price elasticity of the demand E is given by the formula negative dq dp times p over q, where dq dp is derivative of q, but q is given. It is negative 4,500 p plus 41,500. What this means is that everywhere we see a Q, we can use this expression as a substitution for Q. This is usually how it is in an elasticity problem. dq dp is derivative of Q with respect to P. Derivative of negative 4,500 P is negative 4,500, and derivative of 41,500, which is a constant, is derivative is 0. So dq dp is negative 4,500. We then replace dq dp alone with negative 4,500. In the elasticity formula, we have a negative sign, and dq dp is now negative 4,500. Don't forget the initial negative sign times P over Q, but Q is negative 4,500 P plus 41,500. Simplifying this, we get positive 4,500 P over negative 4,500 P plus 41,500. Now that we have the elasticity formula, which is in terms of P, it is the formula in terms of P, we can find out what the elasticity is when the price is 3. Plug 3 into P, we get 4,500 times 3 over negative 4,500 times 3 plus 41,500. Using a calculator to evaluate this, we will get 0.4821. Similarly, we find the elasticity when the price is 5. 4,500 times 5 over negative 4,500 times 5 plus 41,500. Evaluate this, we will get 1.1842. In this case, when the price is 3, the elasticity is less than 1. And when the price is 5, the elasticity is more than 1. In terms of elasticity, when the price is 3, the demand is inelastic because E is less than 1. And when the price is $5, the demand is elastic. If the demand is inelastic, the total revenue increases as the price increases. And so that is why they increase the price from 3 to 5. Remember that the maximum revenue is achieved when the elasticity is 1. And so the elasticity was less than 1, they increased the price, and now the elasticity is 1. Somewhere in there, between $3 and $5 as the price, the revenue is maximized. The revenue is maximized when the elasticity is precisely 1. And so going from the price of $3 to $5, they achieve the maximum revenue somewhere in there. We will need to find the exact price that will give us the maximum revenue, because once the elasticity is more than 1, the revenue is no longer maximized. Again, the revenue is only maximized when the elasticity is exactly 1. So to answer part B, we set the elasticity equal to 1, but the elasticity is 4500p over negative 4500p plus 41,500, and we set it equal to 1. 1 is 1 over 1, so we would cross multiply to get the equation 4500p equals negative 4500p plus 41,500. Adding 4500p to both sides of the equation, we will get 9,000p equals 41,500. Solving for p, we get p equals 41,500 divided by 9,000. With this computation, we will get the price of 4.6111, which we rounded to 2 decimal places because this is the price, $4.61. What this means is that if the price is set at $4.61, we will achieve the maximum revenue. And the revenue is the price times the quantity, where the price equals 4.61 and the quantity is negative 4,500 times p. P is 4.61 plus 41,500. Evaluate this, we'll get 20,755 rice per day. And so with the price of $4.61 times the quantity of 20,755, we will get a revenue of $95,680.55.